Hi everyone, this is Dr. Nally again. I want to continue here our discussion on density. Remember that in the previous video I was talking about the idea that density is a measure of how many particles you have in a given amount of volume for a pure substance. So let's take a look at some density values for different types of substances in different physical states. So if you look here, for example, for gases, you can see that the value of density now, these are all, they're using the same unit to express the density for all of these substances. So you can get a feel for how much less dense gases are compared to liquids. So for example, if you look at these values here for gases, they're in 0.001, 0.00084 grams per cubic centimeters, whereas if you compare that to density of liquids, liquids are about 0.789, 0.88, usually around 1. For water is about 1, right? So if you look at these numbers, you can pretty much tell that the density of liquids are about 100 to 1,000 to 10,000 times more dense than the gases, corresponding gases. Solids, on the other hand, is even more dense because you can pack more particles in a given amount of volume if it's in the solid state. So you can see that the value of the density of solids are higher in general than the liquids, with the exception of mercury, which is the only metal that is a liquid. And it's interesting, it's unique because all other metals are solid, but mercury actually is a quite dense liquid, okay? But that's kind of the exception to the rule. Everything else is basically the solid state is the densest state of all of the physical states, okay? So if you compare, solid carbon dioxide with gaseous carbon dioxide, you'll find that solid carbon dioxide is more dense, okay? So that's kind of one way to appreciate density. It gives you a feel for how many particles you can fit in a particular volume. Of course, density is also useful because it tells you that you have that particular substance if the density is, if you were able to measure its density and has that value. So here's an example on how density could be used to determine the identity of a substance. So remember that density is an intensive property, and as I mentioned a couple of videos ago, an intensive property can be used to serve as a fingerprint for a pure substance, because if the density is a certain value, then you should be able to and you calculate the density and it gives you that same number, then you know that that substance is what you think it is that particular metal, for example. So let's take a look at this question. It says that find the density of pure gold. Okay, either you can use online sources, you can find this in your textbook, doesn't really matter. And then what you do after that is answer the following question. Someone gave you a ring. You measure the mass of the ring on a balance. Let's say you find the mass to be 465 grams. And then you put the ring in, let's say, a graduated cylinder filled with some amount of water. You put the ring in, and then the water goes up by a certain volume, 26.5 milliliter. This is what we refer to as measurement of volume using water displacement. So you put a solid object in water, the water goes up by a certain volume. That allows you to determine the volume of the solid. And the question then is this ring made out of pure gold? Okay, so I'm going to work on this in the next slide, but what I want you to do is give this a try first. Pause the video. This is the advantage of the flip section here. We don't need to take class time to do this, but what you want to do at this point is pause the video and then just try it out on your own, okay? Give yourself 5-10 minutes to work through this problem, and then afterwards go back and continue the video and then see if your answer matches the answer that I worked through, okay? Okay, so to solve this problem, basically we need these two concepts, related concepts. One of them is that the intensive property density will tell us whether this metal is gold or not. And to do that, we first need to find the density of gold, which you can do by looking up, like I said, a table in your textbook, go online. But usually the density of gold is around 19.3 grams per cubic centimeter. So then to see whether this metal is gold or not, we basically just need to calculate the density given by the mass and the volume and see if those numbers match up with our gold density. Now, to calculate the density of our ring, right, we'll use our metal, the ring's mass, which is 465 grams, divided by 26.5 milliliter. Now, you know that this is to be expressed in cubic centimeter, but of course we know we have a relationship between cubic centimeter and milliliter, which is just 1 to 1. So that allows you to cancel this. That's your conversion factor, and then now it leaves you with grams over cubic centimeter, and then we just need to do a little calculation here. And if you do that calculation, you get 17.5 grams per cubic centimeter, and this of course tells you that the ring here is not made out of pure gold. Okay, now it could be gold that's mixed with some other substances, in which case it's a mixture, so the density is not going to be the same. Okay, but in any case it's not the same number, 17.5 and 19.3, so it's not pure gold. Okay, so the last thing I want to mention about this is just this whole idea that you can use this, again, you know, density, just in the example that we just did, to be able to determine the identity of a substance. There are many other ways you can use density, you know, in an experiment and identification of a substance. So, you know, we'll see a couple more of examples of this in class as well as in your questionnaire. Okay.